Hello. Today we're going to be going over polynomials. I hope you had a really good long weekend and stuff, and a good family holiday and stuff. And I don't know, had loads of turkey with stuff. Bars. Right, we're going to go over what polynomials are. The first part of this is just a recap of the last, basically, few things we did before the long weekend. It's a ridiculous amount of questions. What I've done is I've separated them onto 3 separate pages. I'm just going to leave them all up here. So if you're doing it in like on paper version, you can obviously just do them. And then I'm going to go through them here, like on each individual one. So have a quick go at this. If not, I don't know how long this video is going to be, but skip this part if you want to and go through the actual lesson. But I basically, these are going to be on the test, right? So I just basically make sure you can do it again, just in case. Anyway, right, I'll leave it here. Have a go, pause the video, and then unpause. Okay, cool. So, just a quick recap then. So you cannot add or subtract fractions unless they have the same denominator, right? So when you have like 2 and 4, let's just zoom in a bit and actually do that one first. Right, we need them to have the same denominator. Now, what's good about 2 and 4 is the fact that actually, if I multiply 2 by 2, I get 4. So what I'm saying here is if I multiply this whole fraction by 2, I will end up with a denominator of 4, and that means we can add or subtract them or do whatever we want with them. So what I'm going to do is I'm going to multiply this whole fraction by 2, because remember what we do with the bottom, we do with the top, or etc. So times them both by 2, that gets us 2 over 4 plus 1 over 4, because I didn't change that. And then now that we have the same denominators, we can just add them. So 2 plus 1 is 3, and that gets you 3 over 4. And keep the denominators the same. That is your level 1 stuff, because let's be honest, to pass the course, you need to be able to do fractions, even the basic ones. Level 2 then, right, again, we can't do anything. We can't add or subtract them unless we have the same denominator. Now, unfortunately, 5 and 6, they don't go into each other quite nicely. So what we have to do is we have to find a number they both go into. Now, if you're like me and you're just a bit lazy and you don't want to actually think that much, all I do is I just multiply this whole one by 6, because this one has 6 at the bottom. And then I multiply this whole one by 5, because this has 5 at the bottom. And I know if I do that, they'll have the same number because they have to, right? So do 2 times 6 is 12, do 5 times 6, which is 30. Then do 5 times 5, which is 25, and do 6 times 5, which is 30. Now they have the same denominators, I can just add the top. So 12 plus 25 is 37, that gets you 37 over 30. And then if you want to just show off a bit, turn it into a mixed fraction. How many 30s go into 37 is 1, with 7 remainder. Keep denominator the same. Cool. Okay, what about this one? In general, now there are other ways of doing this, but in general, if you see a mixed fraction, turn them into improper, because if you do that, then you kind of like, you don't have to remember all the different methods for all the different like adding, subtracting, multiplying, dividing. Just you go, okay, no matter what, I turn it into improper, and then from there, I do what I normally do for subtracting fractions. So let's do that. Remember how to do that. You do 2 times 5, so do the big number times the bottom number, and then you add the top. So 2 times 5 is 10, plus 1 is 11, so 11 over 5. Subtract. 1 times 3 is 3, plus 2 is 5, so 5 over 3. Notice I haven't done anything apart from turn them into improper. And then we do the exact same thing we did earlier, where we have to have the same denominator. So times this whole 1 by 3, and then times the one on the right by 5, the other one's denominator. Okay, if you do that then, you get 3 times 11 is 33, and 3 times 5 is 15. Do 5 times 5 is 25, 3 times 5 is 15. And then just remember here that you're subtracting, not plussing, and that's probably the most common error. Subtract the top, so 33 take away 25 is 8, so your answer is 8 over 15. Okie dokie. And then this is a ridiculous question. Level 4, honestly, we just start throwing as many things as we can at you, because we're just like, let's see what you can do. Same exact rule as earlier. Don't try to do anything special, right? Just turn them into improper first. So do 4 times 3 plus 2. So 4 times 3 is 12, plus 2 is 14 over 3. Don't forget the minus sign in front of it. Then I've got minus minus, which I'm hoping you agree is a plus. And then I've got 1 times 7 is 7, plus 2 is 9, so 9 over 7. Again, we're not going to do anything. We're not going to try do too much at once. We just turn them into improper first. Then I just go for, sorry, the people have just come in to help clean the room. Then all I do is I just times this whole one on the left by 7. I times this whole one on the left by 3. If I do that, 7 times 7, what am I doing? 7 times 14 is what, 70, 98? 98. 3 times 7 is 21. Don't forget the minus sign. Plus 9 times 3 is 27. 7 times 3 is 21. Now I can just add the numerators. I have a negative 98 and I'm adding 27. And if you think of a number line, I'm going back towards 0. So effectively it's going to become negative 71 over 21. Right? Because 98 plus 27. Well, so the way I normally think about it, honestly, I cheat a bit. I do 98 take away 27, and then I just change the sign, and that kind of helps me out. Okay, and then once you're here, again, if you can do it, then please do. How many 21s go into 71 is going to be 3, because that'd get me 63. And then how many are left over is going to be 9 over 21. The important thing here to do is remember just to put that minus sign in front, and that's how you get full marks. Okay. Hopefully that makes sense. If not, learn it. Go back to the additions and subtraction fractions. Okay, multiplying and dividing. This one's really quick. In fact, so quick that it's not going to take as long at all. Let me just get the pen up. For some reason, it's not coming up. You love the new app. They updated it recently, and it's just loving it, mate. Just loving it. Okay, so when we multiply divide fractions, well, to multiply fractions, you just multiply the top, multiply the bottom. So quite literally, what's 2 times 1 is 2. What's 3 times 4 is 12. When you're here, you should reduce your fraction as much as possible. So look at what 2 and 12 have in common. Well, I can see they're both even, so I can divide them both by 2. So that gets me 2 divided by 2 is 1, 12 divided by 2 is 6. To divide a fraction, it's just we have one step before we can just carry on. The first step then is to do KCF. You keep this fraction the exact same, you turn that into a times, you turn that into a, and you flip that fraction. So it becomes 3 over 5, change the division into a times, and then flip that fraction to be 9 over 4. Once you're here, you just do 3 times 9, which is 27. You do 5 times 4, which is 20. And as always, try and make it into a mixed. So how many 20s go into 27 is 1 with 7 over 20. So, yep, good. And then this one, okay, like as I said before, there are ways of doing it without turning it into improper, but why would you learn all these different methods? Why wouldn't you just turn them into improper and then do the same thing we've done a million times? So 2 times 3, 6, plus 1 is 7, 7 over 3. 3 times 5, 15, plus 3 is 18, 18 over 5. Once they're here, we can just times them. So 7 times 18 is going to be 70 plus 56, so 126. 3 times 5 is going to be 15. And then once you're here, see how many times does 15 go into 126? I believe it's 8. So 8 with 6 remainder. And then when you're here, realize that 6 and 15 can both be divided by 3. And so that gets me 8 and 2 over 5. The main part of this is just multiplying it. Like getting to this point right here is the most important. The rest of it is just like really just finishing off. So as long as you understood the top bit, then the other parts will come with time. Okay. What about here then? So same exact idea, right? But don't try to do KCF until you've turned them in proper. If you try to do too much, you're going to mess up. So 5 times 3 is 15, plus 2 is 17. So 17 over 3 divided by negative. 1 times 6 is 6, plus 5 is 11. So 11 over 6. Now we do KCF. So we keep this the same. We change it into a times, we flip this, not forgetting the negative, and then we just multiply the top. So it's 17 times negative 6. I'm just going to write a negative because I know it's positive times a negative. And then 17 times 6 is what? 60 plus 42, so 102. All over 33. And then if you wanted to, you would turn it back into improper. So that's going to be negative 3. That's 99, isn't it? So then 3 over 33. And then I recognize that 3 and 33 can both be divided by 3. So you get negative 3, 1 over 11. Okay, so that's as hard as the questions get. And then last but not least, these ones. They look horrible, but hopefully it's not that bad. Now, you can only add or subtract terms if they have the same letter. So you see here it's got 3x plus 5x minus 2x. We can add and subtract all of these because they have the same letter. So 3x plus 5x is 8x. I'm just going to write that under it. And then I'm just going to subtract the 2x, which is going to get me 6x. You do not have to show all those steps. You can just write 6x because I know what you're doing. I'm the person marking. What about this one? Oh, I've got different letters. It doesn't matter. Just add the things that have the same letter. So I've got a positive 2x and a positive 6x. Remember the sign in front of it tells you what if it's positive or negative. So I've got 2x plus 6x, that's 8x. And then I have a 3y and a negative y. Now, I would always, just to begin with, write a 1 here to remind yourself that is a negative 1y. And so then it's positive 3y, take away 1y, which I'm hoping you agree, is positive 2y. Cool. What about these? So earlier I said they have to have the same letter. I was technically being a bit cheeky. You have to have the same letter and exponent. So a squared and a squared we can do stuff with, but we couldn't do a squared and a. They're different, right? It's got the same letter, but doesn't have the same exponent. So we do 3a squared, take away 7a squared. That is a negative 4a squared. And then we do a positive 2a, subtract 6a, which is going to get you negative 4a. And then last but not least, this one is absolutely horrific. All you're looking for is anything that has the same letters and exponents. So here, let's just look at the 3ab squared. Is there any other ab squareds? And if we look here, we can see a negative 6ab squared. So I've got a 3ab squared, take away 6ab squared. That is just negative 3ab squared. I then look at the next one. I'm like, okay, I've got 5a squared. Do I have any other a squareds? Yeah, I've got a plus, remember, 1. I've got a plus 1a squared. So that's plus 6a squared. Then I have a negative 6b squared, take away b squared. So again, I'm just going to put a 1 there to remind me. So negative 6b squared, take away another b squared is negative 7b squared. And then the only thing I haven't touched is this negative 1. There is no other number on their own, so it's just minus 1. Okay, hopefully that makes sense. That is effectively everything we've done over the last 3 lessons. I'm sorry I've been, well, the long weekend was a long weekend, right? So obviously it's been maybe 4 or 5 lessons since 4 or 5 days since I've released something, but hopefully that was a good recap. Okay, polynomial then. Another one of these words where it probably is brand new to you, and it's one of those that just comes up all the time. So what is a polynomial? A polynomial is an algebraic expression consisting of one or more terms connected by addition or subtraction. As a lot of words, let's have a look, right? So a polynomial can be defined by the number of terms it has. So just a quick reminder, anything that has a number and or a letter is a term. So all of these are one terms. So negative p, 5x squared, negative 2q, a cubed b, 9. They are all single terms, right? And they are all then called monomials. And you'll notice this, polynomial, monomial. And in general, when you see the word mo in front of something, it does mean single thing. You'll see it in chemistry for certain elements. You'll see it you'll just see it a lot, and hopefully it will start making sense. You also see it in certain slang words as well. Binomial, for the exact same thing, we have binomial, right? So then again, nomial's there. Bi. The way I remember this one is bicycle, right? Bicycle has 2 tires. Binomial has 2 terms. So 2x plus 3. Y squared plus x squared, right? 5 minus 3x cubed, y squared. That's all 2 terms, binomial. And then last but not least, we have trinomial. So again, there's that nomial word, and then in front of it, we have tri. And the exact same way of tricycle, yeah, having 3 tires, 3 wheels, a trinomial has 3 terms. So ax squared plus bx plus c, 10x plus 30, yeah, 3 terms. So a polynomial then is just an expression consisting of one or more terms connected by addition and subtraction. And they have different names for each one. So a monomial, binomial, or trinomial are all different kinds of polynomials. Cool. So we spoke about this before, and I've just kind of went through it once before, but here we go. Like terms are terms that have the exact same variable or letter. Variable. And I'm just going to put in brackets letter there. yeah, variable with the exact same exponents / powers, whatever you want to use there. So exponents, or powers. So, for example then, 3x squared plus 15x squared, 3x squared y and 15x squared y are like terms, aren't they? Because they both have an x squared y. Whereas 3x squared y and 3x squared y squared are not, because they don't have the little, like the y doesn't have the little 2. If it had the little 2 there, they'd be like terms, but it doesn't, and so therefore it's not. Why is it not erasing? Why is it not erasing? Oh no. Please go away. Okay, imagine that went. That'd be wonderful. Imagine a world we lived in. Okay, so if we were going to identify which of these have like terms then, in the exact same way I just did it a second ago, 3x cubed, 2x cubed, and 12x cubed are all like terms because they all have an x cubed. Negative 5x and positive 4x are like terms because they all have just an x. And then positive 3, negative 1, and negative 120 are all like terms because they just don't have a letter, do they? They're just a number. So those are like terms, and we're going to be using this a lot when we add polynomials. So let's have a look at that. So this is a perfect question for adding polynomials, right? You'll see a lot of questions just have random brackets in there. If they have an addition in between the brackets, nothing changes in front of it. So 3x plus 9 plus 2x minus 5, I technically don't even have to have the brackets there. Nothing changed in here. So then I just add it like normal. 3x and 2x is 5x. 9 take away 5 is 4. And if you want me to highlight what I've done there, that's fine. 3x plus 2x is 5x. Positive 9 take away 5 is positive 4. Cool. So when you have a plus in between brackets, the second bracket doesn't change at all, right? And so basically you can ignore it and it just becomes the exact same thing we did here. Let's have a look at some more examples. I've got 4x plus 3x plus 7. It literally just becomes 4x plus 3x plus 7. Then you just add up like normal. 4x plus 3x is 7x. 7x plus 7. Remember, we can't do anything else with that because they don't have like terms. What about here? 8x plus 4 and 12x plus 1. Well, that just becomes 20x plus 5, doesn't it? Because 8x plus 12x is 20x. 4 plus 1 is 5. What about this horrific thing? Doesn't matter, because there's a plus sign there, nothing actually changes. So it becomes y squared plus 3y squared, which is 4y squared. I don't know why it's not writing the 2. I don't know. 2y take away 5y. It's going to be negative 3y. And then negative 6 plus 5 is going to be negative 1. And what I shouldn't have done there is I shouldn't have wrote plus minus. I should have just wrote minus. So it should be 4y squared to take away 3y, take away 1. Okay, hopefully that makes sense. Have a go. Okay, let's go through this quickly. So you should have just got 7x plus 2 for the first one. You should have got 2 plus 6x for this one, because 5 take away 3, right? For this one, you should have got 8x plus 10. For this one, it becomes 2x take away 5x, which is negative... come on. 2x take away 5x, which is negative 3x. Then negative 9 plus 1 becomes negative 8. Negative 4y take away 12y is negative 16y, and then positive 6 take away 8 becomes minus 2. 1x squared plus 1x squared is 2x squared, plus 2x plus 6x is plus 8x, and then plus 5 plus 8 becomes plus 13. If you got all them right, wonderful. What about if it's a minus sign? Okay, this is where a lot of people go, okay, I'm completely lost. What happened? Now, the minus sign then affects everything inside the bracket it's in front of. So you see how it's 4x minus 3 in there? At the moment, if you completely ignore the left-hand side, right, and you just look at 4x minus 3, you'll see that the 4x is positive and the 3 is negative. That minus sign there changes everything to be the other sign. So if it was a positive 4x, it becomes minus 4x. And if it was a negative 3, it becomes positive 3. So then we have that, we can just write that other bracket in front, so 2x plus 8. And now that I have this, I can just do what I've been doing. 2x take away 4x is negative 2x. Let me highlight what I'm doing here. 2x take away 4x is negative 2x. And then positive 8 plus 3 becomes plus 11. Let's have a look at some more examples. So this is 4x, and then inside the bracket is a positive 7x and a positive 1. So the minus sign changes them to negative 7x and negative 1. And then all we do is do 4x take away 7x, which is negative 3x, and then subtract 1. What about this one? Inside the second bracket, it has negative 8x and negative 3. That minus sign in front of this, changes everything to be different. So it was negative 8x, it now becomes 8x. It was negative 3, it now becomes plus 3. So now I just write that other bracket in front of it, and I do exactly what I've been doing. 4x plus 8x is going to be 12x, and then negative 5 plus 3 is going to be minus 2. Sorry. There you go. What about this one? Again, you have a positive 3a squared, you have a negative a, and you have a positive 1, and it's got a minus sign in front of it. So the positive 3a squared becomes minus 3a squared, the negative a becomes positive a, and the positive 1 becomes negative 1. So then I have 7a squared plus 4a minus 3, and I do exactly what I've been doing, right? I've got 7a squared, take away 3a squared is going to be 4a squared. I've got positive 4a plus 1a is going to be plus 5a. And then I've got negative 3 take away 1, which is negative 4. Okay, hopefully that makes sense. Have a go. Okay, hopefully that was enough time. If you haven't, again, you know how to do this. You pause it. Let's go through them. So 10 minus 4 plus 3 is equal to 10 minus 4 minus 3, and that's true. And the reason for that is because it was 4 plus 3 inside the bracket. That's a positive 4 and a positive 3. So then it becomes 10 minus 4 minus 3, which is what that is, right? You could also prove this as well another way. 4 plus 3 is 7, so 10 take away 7 is 3. Right? And then 10 take away 4 is 7, take away 3 is, hold on, what did I say? 10 take away 4 is 6, take away 3 is also 3. So prove it any way you want, but as long as you actually show me something, you're all good. Okay, so what do we have here then? We have, what are you doing? We have a positive 2x plus 3 in the bracket, so it should just be a 7x, take away 2x minus 3. That becomes 5x minus 3. What do we have here? We have a positive 2x and a negative 3, so that becomes a negative 2x and a positive 3. Then, so 5 plus 3 is 8, so 8 minus 2x. This becomes a negative 2x and subtract 5, so 6x plus 8, take away 2x, take away 5. That gets me 4x plus 3, doesn't it? 6x, take away 2x is 4x, 8, take away 5 is 3. We have a negative 8x, so I'm just going to write the first bracket first, 6x minus 5, right? We have a negative 8x, so that's going to become a positive 8x. We have a positive 10, so that becomes a negative 10. Then just add up as we normally, 6x plus 8x is 14x. Negative 5 take away 10 is negative 15. Okay, 4a squared minus 3a minus 6a squared plus 4a. Well, let's write that first bracket first. And then it was a positive 6a squared, so it becomes a negative 6a squared. It was a positive 4a, so it becomes a negative 4a. And then what we have is we have a 4a squared take away 6a squared, which is negative 2a squared. And we have a negative 3a take away 4a, which is negative 7a. And then this absolutely horrific thing, let's just write this first one out first. 3m squared plus 7m minus 6. And then it has a negative m squared. That becomes a positive m squared. We have a negative 4m. That becomes a positive 4m. We have a positive 5. That becomes a negative 5. And then when I'm here, 3m squared plus m squared is 4m squared. Positive 7m plus 4m is positive 11m. Negative 6 take away 5 is negative 11. If you got all those right, you're the best in the world. If not, I hope that me going through it makes sense. And you're still the best, don't worry about it. There's the answers as always. So, there's 4 more questions here. You can go through them if you want to. These are your level 4 questions, aren't they? In fact, we will go through them if you want to, but you can also pause it here and just end the video if you want. Okay, let's do this. So, these all have plus signs in between them, so I'm just going to read it as it currently is. It's 5x plus 2x take away 3x. 5x plus 2x is 7x, take away 3x is 4x. Positive 3... sorry. Positive 3 take away 1 plus 8 is going to be 2, 10, so plus 10. I'm going to rewrite a few of these because it's got a minus sign in front, so it's going to be 3a plus 4 minus a plus 6 minus 4a plus 7, because plus minus in that case, yeah. 3a take away 8 is 2a, take away 4a is negative 2a. Positive 4 plus 6 plus 7 is 17. 3x squared plus 9x squared is 12xy squared. Positive 6x take away 2x is 4x. Negative 8y plus 4y is negative 4y. And then, horrific, we have... okay, we have a half n squared plus 2 over 3n minus 5 over 3. And then take away 3 over 8n squared. It was a negative 3 over 4n, so it's going to become a positive 3 over 4n. And then it was a positive 7 over 3, so it's a minus 7 over 3. Okay. We have a half n squared take away 3 over 8n squared. Can I move down a bit? Hold on. So let's actually use some different colours here. So I've got a half n squared take away 3 over 8n squared. Because they both, well, it's just fractions again, right? So this is basically 4 over 8n squared take away 3 over 8n squared. So that gets us 1 over 8n squared. What I did there was make the same denominators happen, right? Then I have plus 2 over 3n plus 3 over 4n. So again, I need them to have the same denominator, so I'm going to make them into 12. So effectively, it becomes 8 over 12 plus 9 over 12. So that's 17 over 12n, and I'm going to leave it as that. And then I have negative 5 over 3, take away 7 over 3, which is going to be what? Negative 12 over 3? So negative 12 over 3, or you can write that as negative 4. That one is annoying. It's brought on everything. I can't imagine I'm going to have a question like that in the thing. But if I do, hopefully it makes sense. And then last but not least, this is more of an EQAL question. Which of these are true? 3n take away 4 plus n plus 2 is going to be 4n minus 2. 4 lots of n minus 2, so it's going to be 4 lots of n minus 8. And then 5n take away n is 4n. Positive 6 take away 8 is going to be negative 2. Okie dokie. That was a long video, and I'm sorry about that. But hopefully everything's good. Have a good day.